start with?
Oh, I got it.
Ooh,
Believe.
no, you don't start with verb.
Oh god, I used to know it.
What did you use? Yeah.
So I is going to equal V over
R.
R.
And V.
And V
Yes.
equals believe.
I believe. I was just thinking.
What's R? Okay. It is 0.25 inch.
Oh my god, I got that.
Yeah, get that.
Like
I
that
will
one,
not get
Papa?
that.
Yeah.
How am I supposed to remember all these equations?
Did you make up your own equation?
So,
right here.
on B, calculate the magnitude of the force required to pull the rod to the right with constant speed. You're pulling it this way, right? We need a big idea. You're pulling it this way. Which direction is friction going to act?
The opposite.
Opposite.
So one of the things you need to find is the force friction. That's why you have the value of mu. Okay?
Force normal. Force friction equals force
Mu times force normal equals.
I got
force.
0.25.
We get that.
Huh?
It's on, Kayla, it's on here.
Is
It's
it
on your equation.
Yes.
Loki? I forgot.
Okay.
I've seen it.
Now,
I thought it got removed.
here's the story.
No, that one's.
You
I
have,
just gotta find
when you look at this, when you're pulling it this way, what are you going to see more of?
X's.
X's. They don't ask you specifically to do this, but let's just say it. Which direction would be the current in the system? You're pulling it this way. You're seeing more X's. What are you going to do?
Make more O's up.
You need to make more O's, so the current is going to go up.
Counterclockwise.
So the current's going to be going counterclockwise. Okay? Now, the current right here is going up.
Yeah.
Which direction is the magnetic field? In. Which direction is the force acting?
Left.
Same as friction.
So, same as friction.
Gotcha, very good.
So, the force that you have to apply has to overcome two things. It has to overcome force friction, and it has to overcome
Magnetic
The
force.
the
magnetic
magnetic force. So, how are you going to find the force created by the magnet? What are you going to use? Bill. Why aren't you going to believe?
Because that's we don't.
You don't have velocity.
You can't.
Voltage.
Yeah. Now,
Oh, PLV.
which length are you going to use?
Perpendicular. No, the upward force.
Yeah, so you're going to make sure that you use that 0.52 meters,
Yeah.
not anything acting horizontally. Use the 0.52. So, in the name of time, your answer to B is 0.535 newtons.
Is that
Alright.
magnitude?
Oh,
That's the sum total of everything. Okay, that's the sum total
If you
of
have
everything.
force critical to it.
Okay.
Does that have to be the same as this?
Now,
What's
on
friction
C,
equals normal times mu?
you want to calculate the energy dissipated by the resistor in 2 seconds. What do you need to do?
P equals B
Power.
squared L
You
squared
need
B
to
squared
pivot
over
up
R.
first,
Great.
because power is in what?
Watts.
Watts, which is joules per
Second.
second. So if I can find my watts, which is joules per second,
Times seconds.
I can find
B squared L squared
So,
B squared. Wait, how do you your voltage?
your current is 0.25
Your
amps.
resistance. Or yeah.
Now, do you have your voltage?
No, but you could probably find it.
Well, you can believe it. Okay? If you found it up above, you can use that same number.
Wait, where does it say?
Oh, I got
You can find
0.535
voltage.
No, I don't
meters.
want to do that. Where's it?
Is
at?
that right?
You have the current or just
Yeah, you can just do believe.
Energy dissipated is power.
Huh?
Energy dissipated.
But no, because power is joules per
You
second.
multiply by two seconds.
So, your power calculation is 0.187 joules per second. But it's 2 seconds. So you multiply that by 2 seconds.
That's a pretty good GPA.
No, it's a horrible GPA.
Okay, wrong magnitude, wrong magnitude. Wrong magnitude.
That's a really good GPA.
And I'm assuming you're
Okay,
not
now, Work done by pulling the string in 2 seconds. Work equals force times distance.
Yeah.
How much force are you applying?
The newtons.
You found it. You already have that number. That's the 0.535 newtons. How far are you pulling it?
That's that equation.
No.
D equals BT.
Yeah. You're
Oh,
pulling it
no.
at a constant velocity of 1.8 meters per second for 2 seconds.
Hey, my bad, Bird.
So you get
1.9.
1.9 joules. Then it says compares your answers to parts C and D. Provide a physical explanation of why they are equal or unequal. So when you look at your answer to C, what do you get? Yeah, so your answer to C is like 0.38. This answer is 1.9.
Yeah.
Much bigger.
What's the difference?
Yo, Albert and Einstein.
Albert
Albert and Einstein.
Some energy as well.
In which situation did you take friction into account?
Oh, the first one.
That's why, because once you encounter friction,
Albert and Einstein, bro.
that's going to take. On that last one, I'll just send you all the
Rick, just read it all.
And
Send
I don't
everything.
get C.
Send it to
answers to it.
I don't get C.
Yes. So,
Give me some C.
I have to
I have, I believe.
Hey, here's your book
Oh, wait, no.
Yeah, and then voltage, we get it over.
More work.
Can this be open book?
Oh,
It can be.
So less required.
Whoa.
Wait.
What do you mean by that?
But the top score is
I'll take that.
You know, honestly-
Hey, on Magnum. Whoa. Wait, Bert, that's good. Bert, you're an adventurous person, right? Over under 2.5 A's on this test. Over under 2.5 A's.
Oh, we're getting over.
If it's 3 A's, it's over. If it's 2 A's, it's over. The line has to be like
the number of A's in this class on this test.
yeah.
Oh, I take the over on that.
On 2.5. You think we do good?
I take the over on that all day long.
he believes in us, guys.
Yes.
Bert, what is going
They're all
on?
coming from that side of the room.
That's being
Yeah.
believe, bro.
Yeah.
You believe in us. You got that horse.
I can do that.
Yeah.
Whoa!
Adam
Oh, nurse's office.
How many A's do you think?
And you got the same grade.